There are other techniques of solving quadratic equations other than just factoring. Again, a quadratic equation is any equation that can be written in this form, where you have ax squared plus bx plus c equals 0, and the key defining element of this being a quadratic equation is the squared, having a squared term, a squared variable. Okay, so I'm going to show you another technique called the square root property, and this is different than factoring. And what the square root property says is that if you have something squared, a squared equals c, then a equals plus or minus the square root of c. And so what you're doing is you're taking the square root of both sides of this equation. When you take the square root, when you have to implement the square root symbol yourself, remember you always have to include a plus or minus, a positive and a negative. And I'm going to show you some examples of how this works, and hopefully it makes sense. Here we have a couple examples of quadratic equations that we can solve using the square root property. The first one says we have x minus 1 quantity squared minus 16. And so what I want to do here is I want to get the squared part together by itself. And if you're wondering, is this really a quadratic equation? Yes, it is, because if you square this out, you'd end up with a squared term. Okay, so this is a quadratic equation. So first of all, I need to get the squared part by itself. So I'm going to say x minus 1 squared equals a positive 16. From there, I'm going to apply the square root to both sides. And anytime I introduce the square root symbol myself, I have to remember to put a plus or minus into the equation. Okay, now this is helpful because the square root of x minus 1 squared is simply x minus 1. And then I have plus or minus the square root of 16, which I know to be 4. So this is my two solutions then. I get x equals 1 plus or minus 4, which would be x being 1 plus 4 and x being 1 minus 4. So I end up with 5, and 1 minus 4 is negative 3. And there are my solutions. Okay, for the second example, I already have the squared part by itself, so I can just apply the square root to both sides. So I'm going to take the square root of 2x plus 2 squared, and then the square root of negative 3. And here, depending on your textbook, you may say no solutions, right? Because you can't have the square root of a negative. Or if you deal with complex numbers, you'll end up with a complex number. Okay, so here I have 2x plus 2 equals I squared of 3. So that gives me 2x equals negative 2. Oops, and I forgot my own advice. I introduced plus or minus, right, because I have to introduce a square root. So I have negative 2 plus or minus I root 3. So finally, x is negative 2 plus or minus I root 3 all over 2. And from there, there's really not much you can do to simplify. And so there are my two solutions. That's negative 2 plus I root 3 over 2 and negative 2 minus I root 3 over 2. The square root property also helps us employ another technique to solving quadratic equations, and this is called completing the square. And I'm going to show you how that works as well. I'm going to show you how to complete the square with these couple of examples, and there's a process to doing this. And so step one of the process is that you have to write the equation ax squared plus bx plus c equals 0 in the form ax squared plus bx equals a negative c. In other words, you take your constant over to the other side. So in part A, to do that, I just need to bring the 6 over to the other side. So I have negative 6. Okay, now step 2, we need to divide everything by the leading coefficient. Alright, so in this case, since the leading coefficient's 1, I don't have to worry about it. In part B, we'll see that I will have to worry about that, but we're not there yet. Okay, step 3 is kind of what I call the money step. You take the coefficient of your linear term, that's your middle coefficient, you divide by 2, square that result, and add it back into both sides. Okay, so let's try to do that here. I'm going to take my linear coefficient, and I'm going to divide it by 2. You divide it by 2 every time, and I get negative 2. Then I take negative 2 and square it to get 4. And then I'm going to add that back in to both sides. So I end up with x squared minus 4x plus 4 equals negative 6 plus 4. Now this seems like we've made things more complicated, but we actually haven't. Okay, so the last step of this is that the trinomial on the left, so this x squared minus 4x plus 4, will now factor as a perfect square, and they'll factor as a perfect square every time. That's why we call this completing the square. So now this is going to factor as x minus 2 quantity squared equals negative 2. And from there I can do the square root method. So I have x minus 2 equals the square root plus or minus the square root of negative 2. So that's x minus 2 equals plus or minus I square root of 2. And finally, x equals 2 plus or minus I root 2. And there are my two solutions. Okay, now we're going to try this process again on part B with 9x squared plus 3x equals 2. So step 1, I already have my constant over on the right hand side, so that's good. Step 2 now, I need to divide everything by 9. So I'm going to end up with x squared plus 3 ninths, which ends up being 1/3 x equals 2 ninths. Okay, from there I have what I call the money step. I need to take 1/3, divide by 2, which is the same as multiplying by 1/2 to get 1/6. I square that to get 1/36, and then I add that back in on both sides of my equation. Now here, since we're dealing with fractions, the arithmetic looks a little ugly, but you just got to trust the mechanics. Just trust that this works. Okay, so I'm going to have 2 ninths plus 1/36 over here. Now, the trinomial on the left then is going to factor as a perfect square, and it's not obvious what multiplies to give you 1/36 and adds to give you 1/3, but the answer will always rely on this. So this is going to factor as x plus 1/6 squared, and if you don't believe me, just try it out. Okay, now on the right hand side, we have to do a little bit of scratch work because we have these fractions. So just to review how to do that, you get a common denominator. So I need to multiply the 2 ninths by 4 over 4 to get the 36th. Okay, so that's going to end up being 8/36 plus 1 over 36, which ends up being 9 over 36, which ends up being 1/4. So the other side, my right hand side of my equation, ends up becoming 1/4. Now I can apply the square root property. I get x plus 1/6 equals plus or minus the square root of 1/4. Or x equals negative 1/6 plus or minus 1/2. Okay, now to add these, I need to convert my 1/2 to sixes. So I'm going to multiply by 3 over 3 to get 3/6. So now I have x equals negative 1/6 plus 3/6, which would give me 2/6 or 1/3. And I have negative 1/6 minus 3/6, which gives me a negative 4/6 or negative 2/3. So there are my solutions, 1/3 and negative 2/3. Completing the square looks like it's difficult. It's really not. The key step is right here in the middle. And what that allows us to do is fill in the blank on what I need to add on both sides so that my left-hand side ends up becoming a perfect square, as we see in both of these examples. And I've shown you all the caveats. I've shown you that you need to bring the constant over. I showed you need to divide by the leading coefficient. And if you do that and learn the steps, it'll work out every time. The square root property and completing the square are two very useful techniques to have in algebra. I hope this makes sense. I hope you feel like you're confident in employing these techniques when you need to. If you have any questions, please let me know, and thanks for watching.